Hello guys, welcome to another video. In this video, we will be discussing about dynamic tables in Snowflake. So, what are dynamic tables? So, if you look at the heading, like let's assume, I'll just give you a scenario. Let's assume in the real time we do ETL jobs, right? So, I mean the middle lane architecture has gained a lot of attraction. So now in the middle lane architecture, we'll be having three layers: bronze, silver, and gold layer. Let's assume the bronze is a source tables, like we'll be getting from the different source systems and we'll be loading them into the bronze layer. Now between the bronze and gold there is a silver layer. So in this silver layer, what do? Like we want to join two three tables and make into a single table, which will be a source for our golden layer. So I mean when you have a scenario like this where you want to join two three tables and all and make into some separate table, so that that table will act as an input to you. Again we have to create a scheduler, we have to again schedule those jobs and we have to run, right? So to avoid that, in the scheduling part and all, orchestrating that particular jobs whenever we get the data in the first layer, initial layer, like the bronze layer, to avoid the scheduling of the jobs, Snowflake has introduced a new concept called dynamic table. So what is dynamic table? Dynamic table is nothing but a table. Underneath we will have a SQL, and the SQL gets executed whenever you want to refresh. You don't need to refresh manually, you don't need to bother about refreshing, you can just view them in the UI, but it will just handle automatically the refreshment of the table, or the execution of that SQL happens underneath automatically. So we don't need to bother about that orchestration and all, right? It's just taking care automatically. So that's called dynamic. So if you just look into this, dynamic tables make it easier to transform the data in Snowflake. Instead of manually setting up the jobs and schedule, you just define what you want. We don't need to bother about this scheduling of the jobs and all. That's the major purpose of dynamic tables. So if you just go and look into the example, we'll get a very clear picture. So if you see, I've just created the schema and the database I want. So I'm just creating a source table. This PRD, so stage acts like my source table, and it has like four rows. Okay. So now if you just query this particular table, so if you see, we have those four rows here, right? So now I've just created a simple select statement here, but you can write any kind of logic. You can use windowing functions, you can use aggregation function, any kind of SQL. You can use UDFs also. Everything is supported, and here you can use joins also. Everything is supported. The complex logic you can keep here, and using this complex SQL logic, you can create a table. And now if you see, the target lag equal to 20 minutes. So we are saying execute this particular select statement, whatever we write here, for every 20 minutes and put the data into this particular table. Okay. Now if you see, while executing, we have to use this particular warehouse is what we have mentioned. Refresh mode equal to auto, initialize equal to on create. So we are saying automatically refresh for every 20 minutes. And now initial is equal to on create means when we are creating itself, we just create. Sometimes if we do on schedule, while creating this dynamic table, we will not have it. Like while the schedule runs, that means for every 20 minutes. So after 20 minutes, the data gets created into this particular table. That's what the on schedule and the on create means. On create means while creating the schedule itself, load the data, is what it means. So here we can write any kind of SQL and the data gets reloaded. But for some kind of UDFs and some kind of date related functions, it will handle with the full refresh. The whole data has been read from the source systems. I mean from the prod stage table, the whole data will be read. But for just like windowing functions and all, instead of reading the whole data, it will just read only the incremental data alone, not just the whole refresh is being done. Only the records which are updated in the source will alone be read, so that the compute cost will also come down, right, when you just do the incremental load instead of full refresh. So that's the difference we need to know, and we'll see that in the slides when it goes to the full refresh, when it goes to the incremental. So but you understood now how to create the dynamic table and what is dynamic table. So let's create this. So I just created a Snowflake dynamic table. It's like a Snowflake managed dynamic table. Okay, we can even create an iceberg dynamic table also. So now let's go, and if I refresh this and if I come here, dynamic schema, inside dynamic tables, we have this particular table. So now if we just click on this, we can even view everything about this dynamic tables in the UI as well. So if you see, if you want, you can give the description, whether it is working fine or not, the table schema, the access, everything is there, the list of columns, the data preview, just to view the data, that's it, and the graph. This graph shows using how, I mean, here right now I'm just using a simple select statement, but if you use by joining like multiple tables, then that lineage will come here, so you can view it. Now we refresh history, we can view when it has refreshed. So the refresh history, when it has run, every detail can be viewed in this Snowflake UI. So now let's go and just create a similar table, but instead of Snowflake managed table, let's create an iceberg table. So now to create an iceberg table, we should have the iceberg table in our database, right? So if you want to know on how to create the iceberg table in our database, you can watch my other video on how to create the iceberg table. I have explained there very clearly, but for time being, I can create an iceberg table like this as well. So, but to create an iceberg table, we need an external volume. So how do we create an external volume? Using this particular syntax. And what do we need here? Our AWS ARN. I mean, wherever, iceberg table stores the data in some cloud storage, like in some external storage, like an object storage and all, right? So we need ARN for that particular bucket. So that we have to give. And if you want to watch, you can watch my previous video where I have on how to create Snowflake tables in how to create iceberg tables in Snowflake. So now let's go ahead and create one iceberg table. I have this external volume and all already, so I'm not creating again. So I'm just creating iceberg table with these columns. Catalog is equal to Snowflake iceberg table, external volume, iceberg external volume, which I have, and the base location where it has to store. So when I just do this, I have my iceberg table gets created underneath. Now if I want, I can even query my iceberg table, select star from iceberg table. See, I don't have any data because I did not insert, so I'm just inserting 100 rows from the Snowflake sample DB. When you create a Snowflake account, you will get this Snowflake sample database, inside which it's a shared database, inside which we'll have some sample data. So I'm just inserting those rows. That's it. Now if you want, I can just query those. See, these records have come into my Snowflake. That's it. So these records have come into my Snowflake iceberg table. That's it. So now let's see on how we can create a dynamic iceberg table instead of normal Snowflake managed iceberg table. Let's see on how we can create. Everything else the same. Here we just get one more extra keyword called iceberg. Create dynamic iceberg table. That's it. And the column names and the target lag I'm saying to run for every 20 minutes. There is another option here. Instead of 20 minutes, when you keep it as downstream. So what is the downstream for this particular table? This particular customer iceberg. So whenever there is an update in this customer iceberg table, then Snowflake will internally run this particular dynamic table underneath using our own compute only. So whenever we get the data here, this table gets refreshed automatically. That's another option. We can mention the time, or else you can mention downstream, so that whenever the downstream tables have been updated, this dynamic table will also get updated. That's it. But while creating a dynamic iceberg table, we have to even mention the external volume as well. This catalog and the base location is the common. That's it. So now this is how we create the Snowflake iceberg dynamic table. That's it. We have created it. And the last but not the least, here we have to see two more options. If you see here, we have mentioned for every 20 minutes. So in case if you don't suspend it, so every 20 minutes continuously, these dynamic tables will be refreshing automatically. So whenever it goes for refresh, will be charged. So to avoid that, we can just suspend them, because it's just for a tutorial. I'm just suspending them. That's it. To suspend, you have to use alter dynamic table name suspend. That's it. They will be suspended. Now if I refresh, I'll be getting this iceberg table as well here. That's it. So this is how we create the dynamic tables in Snowflake. And the major purpose of creating the dynamic tables is whenever the source gets updated, or whenever the downstream table gets updated, in case if our table should also be refreshed automatically, we don't want the headache of scheduling the jobs, orchestration and all, then you can go with the dynamic table. It is just taking care of scheduling and orchestration purpose underneath. We are just worried about our SQL logic, and that's as per our SQL logic, the data gets refreshed. That's it. This is what the practical implementation on iceberg table is. So let's go and look at some theoretical points. If you see when to use them, just say what you want, not how to do it. So you don't have to mention about the orchestration and all. Just say what this is the output you want in the table. So just give the SQL query. That's it, right? Then those kind of scenarios you can go with. So whenever you want automatic scheduling, you don't want the headache of that. Whenever you want the faster performance, like whenever the source has changed and you want it updated in your table also immediately, and you can view them using the Snowsite or the Snowflake UI. That's it. So how dynamic tables work? So when you create a dynamic table, you provide a SQL query, right? That pulls and transforms the data from one or more base tables or the source tables. So Snowflake automatically runs this query on a regular schedule to refresh the data. How does it run? We mention it. At how much interval we have to run. That is what we are mentioning in the target lag. Or in case if you mention just downstream, whenever this particular table gets updated, then this gets updated automatically. So when to use the dynamic table, which we already said, when you don't want to manually manage the data freshness or dependencies, then you can go with the dynamic tables. When like we have a concept called stream and task, which we see in the next video. So in case if you want to avoid that complexity, then you can go with the dynamic tables. I feel like dynamic tables are the replacement of streams and tasks only, but still both are being supported in Snowflake. So when you have some complex logic, and if you want to, if your Power BI reports or something is being read every point in time, then you can go with the dynamic tables. It's kind of mixture of materialized views, streams, and tasks. I would say dynamic tables is nothing but. So in case if you don't want to have your logic in the stored procedures and all, then you can go with this. So now if you see, there are two types of refresh modes. One is incremental refresh, one is full refresh. Okay, only the changed records have been read from the source systems. That's called incremental refresh. When it uses the full data, when it tries to read the whole data from the source, then it's called a full refresh. So all these joins, group by, windowing, partition by, CTE, when you use all these, it goes with the incremental refresh only. It doesn't need to bother about the whole data. It can find out what are all the records which have changed, and then it reads only the incremental data. But when you use UDFs, or when you use the sequence functions, or when you use like the datetime functions, or when you use some Snowflake functions, then it will go with the full refresh. So that time it reads the whole data from the source and then applies the SQL logic which you write. So in case if you want to query, you can even query the refresh history as well from this information schema. Information schema, so dynamic table refresh history. You can get that. You can just prefix on your table and you can fetch the details. And if you see, if you want to change the warehouse, or in case if you want to change the target lag, then you can alter the dynamic table. Alter dynamic table, the table name, this set warehouse. All this have been taken from the documentation only. And in case if you want to rename this dynamic table, you can even rename as well. In case if you want to change the dynamic table with the new one, you can change as well. In case if you want to cluster the dynamic table, so that the query, when you fetch or when you read the dynamic table, it will return the returns fast, then you can even do that as well. Alter dynamic table name, cluster by the specific column you want the data to be clustered. Cluster is nothing but ordering the data. And in case if you want to manually refresh, if you feel like the data is not being refreshed, or else in case if you have kept the dynamic table refresh as one day, and suddenly in case if you want to refresh the specific data, then you can even refresh as well. Alter dynamic table name refresh, it will refresh. And we saw these two commands, right? In case if you want to pause the refreshment of this dynamic table, then you can use suspend, and in case if you want to resume, you can use resume. That's it. These are all the few things which we need to know about dynamic tables. It's just that we are avoiding the orchestration or the scheduling part, and we are just concentrating on the SQL logic alone, and we are getting a table with just our SQL logic, and everything else has been handled underneath by Snowflake. That's it. Thank you so much for watching.